Okay, we were in the middle of the fourth example, so let's continue with this example. So here we don't need to actually put the -1, we do need the negative, and we don't need parentheses since we're just squaring the x. So this would be the equation in vertex form. And I want you to notice, sometimes vertex form and standard form are exactly the same. So we ended up with the same equation. So our vertex is h comma k 0 comma -9. Our axis of symmetry is x equals h, which is 0. H is 0, so there is no horizontal shift. K is -9, so since it's negative, we're moving down by 9. Our A value is negative, so our graph opens down. And because the absolute value of A, the absolute value of -1 equals 1, there is no stretch or compress factor. Okay. So we have answered all the questions there. Let's move on to the next one. So A is going to be -4. B, we're going to take that 8, the positive 8. But now we don't have a C value, so our C value is 0. We need this for our equation. The name of our equation is g of x, right? So it's g of x equals a x minus h squared plus k. So we need a, h, and k. Let's calculate h. H is -b over 2a. b is 8. 2 times a, which is -4. So we get -8 over -8. So it's 1. So this is my h value. And now we need to find our k value by plugging this into this equation. So we get -4 times 1 squared plus 8 times 1. 1 squared is 1. 1 times -4 is -4. And when we add these two, we get a +4 value for k. So let's plug in a, h, and k into our vertex form. So we get -4, h is a +1, so x minus 1 squared, k is a +4. So we don't have any double signs. So here's the form in vertex form. So our vertex is h comma k, so it's 1 comma 4. Our axis of symmetry is x equals h, or x equals 1. Okay, so h is positive. So we're moving to the right, and we're going to move our graph to the right by 1. Our k value is positive, so we're moving up by 4. Okay, so our a value is negative, so our graph is going to open down. And then the absolute value of a is the absolute value of -4, which is 4. And this is greater than 1, so we have a stretch by 4. Okay, and I believe that is complete. So let's move on to the next example. So here the name of our equation is h of x. So let's just write over here h of x equals a times x minus h squared plus k. What's our a value? It's 2. Our b value is -8. Our c value is 11. We're going to need this for our equation. So h equals -b over 2 times a. b is a -8. 2 times a is 2. So we get 8 over 4, which is just 2. So h is 2. And remember, now we're going to plug that in to find k. 2 times 2 squared minus 8 times 2 plus 11. 2 squared is 4. Negative 8 times 2 is a negative 16. 2 times 4 is 8 minus 16 plus 11. That's a negative 8 plus 11. So we get 3 equals k. All right, so let's create our equation. We have h of x equals 2 times x minus 2 squared plus 3. So we have no double signs again. So that is our equation. Our vertex is h comma k, 2 comma 3. Our axis of symmetry is x equals h, so it's 2, x equals 2. H is positive, so we're going to be moving right by 2. K is positive, so we're moving up by 3. A is positive, so our graph opens up. The absolute value of A is 2. So since that's greater than 1, we have a stretch by 2. Okay, so now let's go ahead and do our next example. So in this case, A equals 3, and we need that for our equation. B equals 12, and C equals 16. The name of our equation is f of x. So we'll just write the generic vertex form right here. Okay, so now let's calculate h. H is negative b over 2 times a, negative times 12 over 2 times 3. That's a negative 12 over 6 is a negative 2, so that's our h value. K equals, well, we're going to have to plug that in here. 3 times negative 2 squared plus 12 times negative 2 plus 16. Negative 2 squared is 4. 12 times negative 2 is a negative 24. All right, so this is going to be 12 minus 24 plus 16. Well, 12 minus 24 is negative 12 plus 16. That's going to give us a value of 4 for k. So let's plug a, h, and k into our formula for f of x. A is 3, h is a negative 2, k is a positive 4, so now we have to write it again because we do have a double sign. We have to get rid of that double negative, so that becomes a plus 2 plus 4. So here's our new equation. So our vertex is h comma k, negative 2 comma 4. Our axis of symmetry is x equals h, so it's x equals negative 2. H is negative, so instead of going right, we're going left by 2. K is positive, so we're still going up, but this time by 4. A is positive, so our graph opens up. The absolute value of A is the absolute value of 3, which is 3. 3 is greater than 1, so we have a stretch by 3. Okay, I think this is our last example. So A is negative, remember that's a 1 in front, negative 1. B is a positive 8. And C is a negative 17. We need this for our equation. The name of our equation is g of x. So we'll write down the generic form. All right, so let's calculate our h value. So it's negative b over 2a. So it's negative b is 8 over 2 times a negative 1. So we have a negative 8 over a negative 2, which gives us a value of 4 for h. So when we calculate k, we're just plugging our h in here. So we have -1 times 4 squared plus 8 times 4 minus 17. 4 squared is 16. 8 times 4 is 32. So that's going to be -16 plus 32 minus 17. This is going to give us a positive, whoops, come on, there we go, a positive 16 minus 17. So our k value comes out to be a -1. So now we can plug these in to get our vertex form of our equation. A is -1, h is a positive 4, k is a -1. So now we can reduce this to just a negative. X minus 4 squared, and a plus and a minus gives us a -1. Okay, that's my equation. My vertex is h comma k, so that's 4 comma -1. My axis of symmetry is x equals h, so that's x equals 4. My h value is positive, so I'm moving to the right by 4. My k value is negative, so I'm going down by 1. My a value is negative, so my graph opens down. The absolute value of a is the absolute value of -1, which is 1. Well, because the absolute value of a equals 1, I have no stretch or compress. So I am done. All right, so that's how I would like you to do it. I'd like you to find A, B, and C. I'd like you to calculate H and K. You should find your vertex. Tell me whether there's a vertical or a horizontal translation and by how much and in what direction. Tell me whether the graph opens up or down. Tell me if we have a stretch or compress and by how much, or if there is no stretch or compress. I'd like the equation for the axis of symmetry, and then I'd like you to write the equation from standard form back into vertex form like I did in all of my examples right here.